quantified a set of trace elements in a glass certified reference material that was put out by the USGS, or the Geological Society. So this is a pretty common technique in geology and geochemistry, is to analyze these glass samples for this range of trace elements. So specifically for geology or geochemistry, these trace elements are important for determining the material's origin, determining what sort of chemical processes it went through in geologic time. But what this also demonstrates is the ability to measure these trace elements for things like contamination or process control when we're creating a product and verifying that that product is going to meet the quality and the safety standards that we expect it to. Or maybe we're creating a brand new material and we want to make sure that it has the purity that we anticipate. And so it can be a challenge to directly analyze a solid material and simultaneously get those low mass and high mass elements in a single analytical session. But what I'm going to show here is a study where we quantified the results of the GSE-1G, that's one of the reference materials that you see on the right there, by using the 2G as a calibrant. So these are both certified reference materials. They're the black glasses that you can see mounted in some epoxy there. So we're analyzing the black part of it. And we have those certified values to know what the exact concentrations of these trace elements. So the next two slides, I'm going to show you the results. So what you're looking at here are the major elements on the left and some of the minor elements and trace elements on the right. So they're on two different scales, just so you can see them, since we've got, major elements in tens of weight percent versus the minor elements in the hundreds of parts per million. But what you see are the blue bars, which are the results quantified by the Massbox, again, treating that 1G as an unknown, and then comparing those to the certified values. And the error bars on the Massbox's results, those are going to be the standard deviation across multiple raster areas. When we do a bulk composition, we'll do multiple millimeter scale raster areas in order to average across thousands of mass spectra to get a good bulk composition of the material. And then we look at those standard deviations in order to get a sense of the uncertainty. And then the error bars on the certified values were reported on the certificate of analysis. And so you can see that, not only can we quantify those major elements as well as those minor elements with a high degree of accuracy, we're measuring the lithium, the beryllium, as well as the metallic elements. And then on the next slide, you can see all of these rare earth and other trace elements all the way up to thorium and uranium. So again, that lithium to uranium, quantifying in the hundreds of parts per million these trace elements just directly from a solid material, all within about 30 minutes.